I like example 5. I like example 5. You know what? I'm just going to tell you, there's going to be roller coasters on your test. I guarantee it. Probably at least 2 on the written section, because I love roller coasters. They're great. It says this: suppose the roller coaster below is at rest. I would probably mentally underline the phrase at rest. That tells me something. At the top of the first hill, it's given a very gentle push and it starts to roll. How fast will it be going at location A? I think, Tyler, the first thing that I would do is I would realize this is my initial location. That's my final location. I might add that to the diagram because I've written something down. I feel better. How on earth are we going to solve this? Well, first of all, Gibson, what are they asking me to find? Speed. Here's what I said. Look at the picture. Is there a change in height? Is there a change in speed? Is there a yucky, curvy path? That's when we're going to use the law of conservation of energy. Okay? So I'm going to start out by going K E initial plus P E initial equals K E final plus P E final. What did we do next? We asked, are any of, also it doesn't mention to friction or anything. I'm not going to include heat. What did we do next? We asked, are any of these zeros? So let's think about this here. When is kinetic energy 0? Sorry? When V is 0. Is there a time when V is 0, when we're at rest? Okay, so I can cross this out because V is 0. Okay. When is gravitational potential energy 0? When H is 0. Is there ever a time when H is 0? So I can also cross out that one. So this really complicated situation actually starts to get not too bad. This is what this is how, if you're wondering, when I'm standing in line on a roller coaster, how I can figure out how fast we'll be traveling at the bottom of the first hill. First of all, what's my equation for potential energy? So this is going to be mgh initial. And what's my equation for kinetic energy? So this is going to be a half mv final squared. Oh, I notice one more thing. Gibson, my friend, is there an m in this term? Is there an m in this term? Is there an m in everything? What does that mean? Have you been on a roller coaster before? Yes? Before you got on the roller coaster, did they make you step on a scale? Did they have to measure your mass? Do they have to spread out heavy people and light people? Do they have to make sure that all the cars are full or none of the cars? No. Do you know why? Because it turns out for roller coasters, the masses cancel. If that was not the case, you would have to step on scales. We would have to carefully spread out evenly all of the masses, or we would only have a certain amount of mass that could go on if the masses didn't cancel. Oh, will an empty car make it through the track the same way as a full car? Why? Masses cancel. What are we trying to find? Okay. Also, I would have, this is what I do in line, then I can figure out my speed. I would also have no problem giving you the speed at the bottom of the hill and asking you to find how high the hill was. How am I going to get the V by itself? What am I going to do with this 1? Technically divide it. Am I going to bother doing that? No. What about this 2? Where is this 2? On the, I'm looking for the bottom, so it's dividing, so how will I move it over? Okay, so I'll get this. 2gh initial equals V final squared. V final what? So? Yeah. Now, I've done this often enough that I kind of have memorized this equation, and if I'm standing in line, because I don't have a calculator, well now with phones I do, but before I was carrying a phone, I would use 10 instead of 9.8, and I would do some rough math, but I was only interested in rough numbers. How fast am I going roughly? But in this case, we can be even more specific. The speed at the bottom of the first hill is going to be 2 times 9.8 times 90. Which is what? This might work out evenly. Does it work out evenly? It might. I'm doing some quick math in my head here. I think everything ends up being a perfect square inside there, so I think it should square root evenly. I don't know what the answer is. Sorry? Do me a favor. Could you multiply that by 3.6? How fast is that in kilometers per hour? I'm going on this coaster. In fact, this coaster, I'll stand in line for a couple of hours for. This looks like a pretty good, intense one. 150 clicks? Oh yeah, that I'll go on. 100 clicks, I'll stand in line for half an hour, maybe an hour. 30 kilometers, 50 kilometers per hour? Even the one at Playland, the old wooden coaster, Colton, it's a classic and it does give you some good accelerations, but also it's kind of meh. What makes it scary is the wood flexes, the wooden frame ones, and so you do feel a bit more G's than on a steel coaster. And also because it only has a lap bar, it doesn't have the shoulder restraints, and so you feel like you're going to get thrown out of your seat. That makes it scary, but in terms of actual physical G's, eh. Okay. Well done. B. Jesse, what are they asking me to find in B? Okay. Well, we got two options. Look up. Don't write this down, but look up. I could either go like this. Let this be initial and this be final. The only issue then is I'd be using this answer to find the next answer, and I'd try and avoid that. Or I could go like that, which is probably what I would do. So, okay, here we go. Is there a change in height? Is there a change in speed? Is there a yucky curvy path? This is a job for conservation of energy. I'm going to start out writing the same thing as I did before. KE initial plus PE initial equals KE final plus PE final. Are any of these zero? We're still starting out at rest. But we're never on the ground. Okay. It's going to be mgh initial equals a half mv final squared plus mgh final. Is there an m in the first term? Is there an m in the second term? Is there an m in the third term? Is there an m in everything? Have you been on a roller coaster before? Before you got on the coaster, did it make you step on a scale? Why not? Turns out the masses cancel. That's good. That also means little kids and grown-ups can go on this ride. What are we trying to find? Okay. How? Well, there's the VF right there. Let's be more meticulous. I guess the left side is going to drop down like a domino. And then I think, well, what would I do next? Yeah, I would minus GH final. I wouldn't divide 2, I would divide a half. I would divide by 0.5 because that 1/2 is multiplying. Or what I could do is I could put the top in brackets and multiply everything on the top by 2. I would probably divide by 0.5. Actually, that's a lie. There's a shorter way to do this, but I'll show you on the next question. that whole mess. Okay. So I'm going to get this. VF is going to be the big square root, G, 9.8. Initial height, 90 minus 9.8. Final height, 50. All divided by 0.5. How would I type this into my calculator? I would, and some of you have the fancy schmancy fraction buttons and square roots. You can probably do this in one step. Cole, I would probably go, brackets around the top, 9.8 times 90 minus 9.8 times 50, close bracket divided by 0.5, and then I would go square root, answer button. I think it's going to work out evenly. First of all, at the top of the second hill, am I going to be going faster than 42 meters per second or slower than 42 meters per second? So a bit of a built-in error check. I know it's going to be less than 42. 28. And if you do it that way, Josh, I'll give you full credit. But there's actually a much, much better way to do it. At the top of the third hill, not shown, the coaster has a speed of 12 meters per second. How high is the third hill? Okay. You know what? First of all, what's our speed? Is the third hill higher than 50 meters or lower than 50 meters? And how do I know? Lower? How? Why do I think that it's higher? If it was lower, what would this speed be? Bigger than 28. Wouldn't it? Right, Jesse? If it was lower, you would have lost potential. And energy's got to go somewhere. It would be kinetic. I think the third hill is actually higher than the second hill. I'm going to sketch it in. It's going to be, I don't know, something like that. I don't care. I just want to visualize it so that I can go scribble, scribble, scribble and say, okay, that's final. Are any of these 0? Yeah. In fact, Jesse, you okay with that argument? You're looking like you don't believe me, right? The slower you are, the higher you must be. The faster you are, the lower you must be, because you're going faster at the bottom of the hill, not at the top of the hill. And 12 meters per second is pretty slow. In fact, I'm going to guess that we're not much lower than the original hill, because we haven't picked up much speed at all. So again, I'm going to start out with conservation of energy. And again, I can say, yay. mgh initial equals a half mv final squared plus mgh final. Mara, have you gone on a roller coaster before?
Yes.
Before you got on the roller coaster, does it make you step on a scale? Why not? Turns out, that's kind of nice. What are we trying to find? The final height, that right there. Okay. Let's go meticulously. I guess the GH initial is going to drop down like a domino. I'm going to minus 0.5 VF squared to get that term over. Yep. And then I'm going to put the H final over here on the left because that's where we're used to seeing it. Okay? So we want to get comfortable moving stuff around with the law of conservation of energy, GG equation. So it's going to be 9.8 times 90 minus 0.5 times 12 squared, all divided by 9.8. Not convinced this one will work out evenly. Let's see. Brackets around the top. Got your calculator out? You have your calculator out? Get your calculator out. Not your phone. Oh, you don't have a calculator here?
No.
Where is it? Where's your binder? Okay, we'll pause the video for a second. Good, we all got our calculators. 82.6. Okay. The bit of a built-in error check couldn't be higher than 90 because that would be magically gaining energy. 82.6, that seems about right, because at 90 we were at rest, so we picked up a little bit of speed, but not much. We've lost a little bit of height, but not much. Oh, not 82.6, what should I really say? 82 point, round off properly, Mr. Duick. Okay. Example 5. Roller coaster travels as shown below. At point A, it is moving at 12 meters per second. If we ignore friction, how fast will it be traveling when it reaches point B? Any suggestions on how I might want to tackle this? Is there a change in height? Is there a change in speed? Is there a yucky curvy path? Yeah, I'm going to use the law of conservation of energy. I guess initial is going to be right there. Final is going to be right there. And let's write out the law of conservation of energy. They said ignore frictions. I don't need to worry about heat. It's going to be KE initial plus PE initial equals KE final plus PE final. And then I always pause and I ask, are any of these zero? Well, kinetic energy will be zero if we're at rest. Clover, are we at rest right here? Are we at rest right here? Better not be. That'd be a boring ride. So I can't cross out any of the KEs. Can I cross out any of the potential energies? Are we ever on the ground? Ah. Okay. A half mv initial squared plus mg h initial equals a half mv final squared plus 0. So, do you like roller coasters? You've been on a roller coaster before? You have not. My goodness, we have to change that sometime. Well, if you take Physics 12 next year, we'll try and change that. Had you gone on a roller coaster, would they have made you step on a scale ahead of time? No. Can little kids and grown-ups go on roller coasters together? How come? Yeah. And then look up for a second. Now, one way to get the V by itself would be to divide by 0.5, square root. But I'm going to show you a bit of a clever trick. I notice what's in front right here, a 1/2. What's in front right here, a 1/2. I'm going to actually clear fractions. What I'm going to do, and I'm doing this to show you something. You don't have to do it this way. If you're happy going divide by 0.5 square root, you'll get the right answer. But I'm going to go times by 2, times by 2, times by 2. I'm going to multiply everything by 2. Now, why did I do that? Because 2 times a half is 1. This whole term cancels. And 2 times a half is 1. This whole term cancels. And I get this. VI squared plus 2GHI. And if you don't mind, I'm going to write it like that. And then everybody look up for a second. Here's really why I did that. I'll wait till everybody's looking up for a second when I say everybody look up. Okay, write it down, and then everybody look up for a second. Okay, keep looking up. Well, we're waiting. Okay? And, with your eyes open, Matt, that helps. All right? Vs, don't write this down, equals Vi squared plus 2AD. Is that an acceleration? Is that in meters? This, I promised you way back when I did Vf squared equals Vi squared plus 2AD. I don't know if you remember, I never derived that equation with you. I said, you know what, it kind of pops out elsewhere. It pops out from conservation of energy, G. Now you can pick your pencils up. Clover, keep going. How would I get the Vf by itself? Yep. Vf is going to be the square root of, was it 12? 12 squared plus 2 times 9.8 times 18. What do you get? 22.3? Yep. Just for giggles, could you multiply it by 3.6? Meh, that's a C plus coaster. Okay. If it's a lineup of like 20 minutes, I'll go on it. If it's lineups of like 2 hours, yeah, I'll probably go somewhere else. Good stretch, Oliver? Okay. How fast should we be going? 22.3. Suppose we use a radar gun and we clock the coaster only going at 15 meters per second. Where has that extra kinetic energy gone? Friction and heat. How much? So if the coaster is only traveling 15 meters per second at point B, how much energy was lost to heat? Now, Noor, I'm going to have to do conservation of energy again. But I'm going to have to include heat. Is that okay? Which ones were 0? Okay. I want to get the heat by itself. How will I move this over? Say it again. You're right. It is just subtracted. This is a weird one. For some reason, and I don't know why, every year I have kids that look at this and say, oh, you would divide it over. It's not multiplying the heat. There's a plus sign there. We're going to subtract it. So it's going to be this. KE initial plus PE initial minus KE final. And if you don't mind, Noor, I'm going to put the heat over here, and I'll put it in red because fiery heat. Well, we've done the hard work. What's kinetic energy? A half mv. Oh, it's going to be a half mv initial squared, and then mg H initial minus a half mv final squared. Yes? Oh, Noor, is there an m in this last term? Middle term? First term? Is there an m in the heat? Do the m's cancel? So I've lied to you a little bit. The masses don't cancel in a roller coaster, except if we grease the coaster down a whole bunch, if we make friction as small as possible, if we make this number as close to 0 as possible, then the masses become negligible. We can ignore them. An empty coaster and a full coaster will make it through just fine, and there's a massive error margin on either side. We're good. So I fibbed a bit when I said to you that the masses cancel, Mara. They become negligible in real life. All right, let's crunch the numbers. 0.5. I've scrolled down, Noor. What was the mass? They must have given it to me.
225.
Okay. And then my initial speed was 12, right? Don't forget the squared. Plus 245 times 9.8 times, what was that, 18? Was the height, I think? And then minus 0.5 times 245 times, 15 is the, not 22.3, 15, and don't forget the squared. How much energy did we lose to heat? You should, if you got a good calculator, and hopefully most of you do, be able to type this just in one line. 0.5 times 245 times 12 squared plus 245 times 9.8 times 18. Take away 0.5 times 245 times 15 squared. Do you get 33,300 if I go to 3 sig figs? Units, Noor. Joules, heats energy. Yep. Yep. Okay. What's your homework? So if you look at number 1, this is kind of similar to both the skate park and the very, very first example that Tyler and I did. I think it was Tyler and I, where we had the mass sliding down the ramp at the very, very beginning. Here's what I mean. Mechanical energy, first of all, is total energy. That's like that yellow bar on the skate park. Number 1 here. What's my potential energy exactly as a number? Okay, I can say this. Doink. What's my kinetic energy? It's going to be a half mv squared. Could somebody crunch that really quickly, please? 240? Is that right? No, yes? Is that right?
Oh, I forgot squared.
I don't think it is. You forgot the squared? Really? So what is it? That sounds better to me. 1,920 joules. What's the total energy? In your head, 0 plus 1,920 is? That's the mechanical energy. And you can fill that anywhere it says ME. That's your total energy. 1,290, 1,290. From that, I think, Josh, by looking at these numbers, you can figure out how much potential energy you have, what's left over for kinetic energy, how fast you must be going. And here at the top, when you're stopped, I can figure that out. The kinetic energy is 0. How much? I can even tell you how much potential energy it's going to be then. 1,920. You can figure out the height from that. Okay? So I'll let you try number 1. Answers are there. Number 2, here's our roller coaster. It's very similar to number 1 in that mechanical energy is going to be total energy. Kinetic potential you can figure out from the numbers that are there. 3 is good, same idea, except it's getting a bit more complicated in our roller coaster design. 4 is good. 5 is good, a little word fill. 6 is good, and 7 is good. Yeah, I assigned everything.